Hi class, this video is to review the practice problem in the textbook. So I'm looking at example 3.1. And what I want to show you is how to input the data into an Excel chart. Although that's not necessary for this problem, you're just trying to learn how to calculate excavation and backfill. I'd like to show you how to properly use the Excel chart so in the future when you have to do it, you know what to do and how to use the formulas. Okay, so to start, the first thing that we're going to do is we have an Excel chart set up, and I just copied one that was in the book. So on page 69 of the book, it gives you an example, and I just use that as a template to create my own chart. The first line, what we're going to do is we are going to type what we're solving for. So in this case, I'm solving for a trench. I want to know the excavation and backfill for this specific trench right here. So the trench is this area, this kind of chunk that I'm drawing a box around right now. The first step in calculating the trench is we have to define some of our knowns and unknowns. So to calculate volume of a trench, we need to know the center line length, the average width, and the average depth. We know that the length of this trench is 100 feet. However, we don't know the average width or the average depth. So that's one of the first things we have to solve for. And as you can see in your textbook, all your side calculations should be shown on your Excel sheet. So the first thing I'm going to solve for is the average depth. So on my sheet here, I'm going to type average depth, and then I'm going to put the formula, which is going to be, well, actually, I'll show you that in just 1 minute. So to find the average depth, we have to take a look at, again, our picture, our image here. So we see we have a 100-foot trench, and on one end, on the left side, we have a 5-foot deep, and then on the right-hand side, it's 7 foot deep. So to find the average for the depth of this trench, I just simply add 5 plus 7 and then divide by 2. It's averaging any numbers like you would in mathematics. So for my average depth, I'm going to type 5 plus 7, and then I'm going to divide by 2. And then underneath that, I'm going to make it a little bit more clear, and I'm going to put 5.00 feet, and I'm going to put 7.00 feet. I'm going to put a little underline underneath that, and then I'm going to write out what that equals, which is 6.00 feet. Now, if your numbers are not coming up like this, like how mine are shown with the 2 decimal places after the number, what you can do is right-click in this box, go to Format Cells, and then select Number, and make sure that you have 2 decimal places selected. Okay? So again, that's clicking on the cell, right-click, Format Cells, go to Number, and then select 2 decimal places, and then say OK. Alright, so I'm showing that average depth of my trench here is going to be 6 feet. Alright, so the next thing I have to calculate is the average width. So to find the average width, we have to take the width of the footing, we have to find the width of the workspace, and then we also need to know the cutback. And that will give us our total width. So let's go on with finding these things. So first, the width of the footing. So if we take a look at our figure, we see our footing down here, which is this rectangular shape. And we can read from the drawing that the width is 3 feet. So width of the footing, we're going to just type in 3.00 feet. Okay, and I'm going to push this 3 feet over as far as I can in my box. My workspace, the workspace is this space allotted on each side of the footing. Okay, and there's space allotted because in theory someone would be standing in this trench and they would be building the formwork for the wall and to be able, so they could pour the concrete. Okay, so there has to be enough space for them to be able to stand in there and work in there. So the workspace is a foot on each side of the trench. So I have a foot and a foot. So my total workspace is going to be 2 feet. So I'm going to put that inside my problem as well. And again, I want to just space these numbers so they kind of line up with each other. Now the cutback. The cutback is this angled line here. And it's often called the angle of repose. You might see it worded that way as well. And what that does is it provides safety while someone's working in the trench. So the angle of repose is usually determined as a safety standard, and it can't be so steep, like it can't be totally vertical, because what's going to happen is when you start digging the earth away, if it was totally vertical or if it wasn't angled enough, if someone's inside of this trench, the earth could fall in on them and kill them, and there have been instances of that happening. So this angle of repose or cutback has to be added to these trenches for safety reasons. To find the cutback, it's going to be 2 times half the depth of the trench. So that sounds confusing, but let's just think about that. So the depth of our trench is 6 feet. We calculated it up here. 5 feet plus 7 feet divided by 2 was 6 feet. That's the depth of our trench. So half the depth of the trench is 3 feet. But then to find the cutback, it's times 2 because it's on both ends. So it's going to be a total of 6 feet. So the cutback is going to be 6 feet. Now there's another way to look at that that's not quite as confusing, and that's by looking at this 1-to-1 ratio here. So now we look at the width of the footing, the workspace, and the cutback, and I'm going to put a little line under the cutback to indicate that we're adding all these together. So we add 6 plus 2 plus 3, and our total width is 11 feet for our trench. Okay, so the next thing that we want to find is the excavation of the trench. So how much earth are we going to have to excavate in order to create this garden wall trench? So over here, I'm going to type excavation trench, and I'm just going to abbreviate it. I put it all in caps so I know that there's headings for each one of these. It just helps me keep track of myself. And to find excavation of trench, or the volume of excavation, we are going to multiply the center line length, which we know, again, it's 100 feet, times the average width, which we found up here, which was 11, and then the average depth, which we found to be 6. So now we can insert those numbers into the columns here, length, width, and height, or in this case, depth. So for length, we have 100 feet, so 100.00 feet, because I'm going to use decimal feet. The width was the 11.00, and then the height, or the depth, is going to be 6.00 feet. Okay, so now over here in the total column, to multiply that out, move my total column, you're going to use the tools in Excel. So to get something to multiply, you write equal the sum of, and then do an open parenthesis, 100, and then hold down control, times, hold down control, select 11, times, hold down control and press 6, or go over 6, close your parenthesis and type enter. Now it's giving me an error here because I put the feet markers in there, and it doesn't like that. So if I take one foot out, if I take the foot out of each one of these and just put the numbers, it should help correct my value. So 100, 11, and 6. And then the units, what we're going to do is that gives us 6,600, and then it's going to be cubic feet. So I'm going to write CF for cubic feet. And then remember, when we do things like excavation of soils and when we do concrete, we actually measure in cubic yards. So then we're going to divide this by 27 to get cubic yards. So I'm going to click on this, or I'm going to click on the cell below it, and I'm going to write this equals the sum of this divided by 27, close my parenthesis and hit enter. Okay, and then I want to remember to round to 2 decimal places. So I'm going to right click on this column, format cells, go to number, say 2 decimal places, and then say OK, and then show my units as cubic yards. So I have 244.44 cubic yards, and we'd probably actually just say 245. Now, what you might be wondering is well, you didn't show your units here, and how do I know I divided by 27 here? I didn't show my side calculations, and that's true. So you may want to actually indicate over here, if I click on it, I can see I divided by 27, but you may want to write something over here that says 6,600 cubic feet divided by 27, just so that you have that information showing over in your side calculations. And for the purposes of our homework, I would actually like you to write out all of your calculations. So if you are using this Excel spreadsheet, over on the side you can even type every single one of your calculations or handwrite it and also attach the Excel spreadsheet. I want you to get used to doing both. We're just not to the point yet where you can only show me your Excel spreadsheet. Okay, so then the next step we want to do is the volume of backfill. So we're going to just type backfill here. Backfill the trench. And in order to find the backfill, the volume of backfill, you take the volume of the excavation minus the volume of the footing and minus the volume of the wall. So the backfill is just simply putting soil back inside of this hole that you dug out. However, when you took the earth out, this footing and this concrete wall weren't here. So when you go to put the earth back, you have to account for the fact that now you have something sitting in your trench. It's taking up space, so you may need less earth. Now there also is something called the swell factor, which we'll discuss a little bit later, but in this equation we're not considering that. So we have to just consider that the footing and the wall are inside of this hole, so now when we put the soil back, it's going to be a little bit of a different number for the backfill. Okay, so volume of backfill. Let's do some side calculations here. So we have the volume of excavation. That's up here. We already calculated for that. We need to know the volume of the footing. So I'm just going to type volume for footing, volume footing. And to solve for the volume of the footing, we have to again take length times width times height, or length times width times depth. They're the same thing. So we know that we have a 3-foot footing here, and that we have to read our book to see if there's any more information given about that footing. Yes. So the width is 3 foot, the height is 2 feet, and then the length of the footing, remember it runs the entire length of this, is 100. So the volume of the footing, if it's length times width times depth, you're going to write volume of the footing, length times width, times height or depth. And we're going to put that in as 100 feet. Oh, actually, sorry, we can just use this right here. We could go 100, 3 feet, and then the height is 2 feet. And actually now, since you've already put in this equals sum formula, you can copy and paste this from one part of Excel to the other. So I'm going to click on it, hit Control C, and then hit Control V, because I'm doing the same calculation here. I'm taking 100 times 3 times 2, and that's giving me the cubic feet. So I end up with 600 cubic feet. That's the volume of the footing. All right, the next thing is the volume of the wall. And again, that's going to be the length times width times height. You can put it here just for yourself to remember. So the volume of the wall, so that's we have an 8-foot high masonry wall here, and it's 1 foot thick, and it again runs for 100 feet. So the length is going to be 100, the width is 1 foot, and then the height is 8 feet. And again, I'm just going to do Control C on this formula, and then Control V, V is in Victor, to paste it. And then that's going to be cubic feet. So now I have cubic feet, and cubic feet, and I need to use all of those to calculate the total volume of backfill. So I'm going to put total